Hey everyone, this is the answer key for the practice test that's been posted. I've teed up a bunch of the answers to make it go more quickly. You should have about 45 minutes to do this. You'll see I can do it in about 10 minutes, so hopefully you guys can complete it in that amount of time. In the beginning here, we're talking about which of these things are functions. Remember, a function is something that just gives you one unique output for every input. So think about things that pass the vertical line test. So is this a function? Well, if I plotted these, I'd go out to 3, and I'd go up to 5, and then I'd go out to 3, and I'd go up to 6, and then 7, and then 8, and then 9, and that fails big time the vertical line test. So no, that is not a function. If I plot this, now I'm going out to 3 and up 5, then out to 4 and up 5, and out to 5 and up 5, and now I'm getting lines, dots like this. So that does not fail. So yes, that is a function. The domain here seems to be 3, 4, 5, 6, 7. The range, the output, seems only to be 5. All right. So here now we can describe functions in 4 different ways at least, with ordered pairs, with graphs, with words, and with equations. Here's one in words. And the words don't always have to be about numbers, but this one happens to be. So the input is a person's last digit of their phone number. So for me, it happens to be a 7. And the output is the number of the month of their birth. I was born in September, so this would be my coordinate point. I would think there must be a lot of people out there who have 7s, but their birth month is not going to be always September. So you could have some 10s, you could have some 2s, you could have some everything. So this is not a function. We're getting different outputs for that same 7-digit input. If this had more specificity to it, if it was a person's ID number and there's only one unique person going in, then lots of people can have the same output, but you have to be able to differentiate the inputs. Okay, so now onto this. This is an equation for a line in standard form. I think the best way to graph standard form is with the intercept method. It's very easy. We're just looking for points when x is 0. I can cover up the x. Y then has to be 3 times 8 to give me 24. That's the only number that works. Then I can do the other way around where y happens to be 0. And again, x is going to be 8 because 8 times 3 now is 24. Okay, to graph these, I just have to be careful that if I go left and right nothing, that's 0 for x. I go up 3. And if I go out 8, 4, 5, 6, 7, 8, then I go up and down nothing. And there is my line. And you want to label it. You want to give some scale. There's 5, and maybe write 3x plus 8y equals 24 on there, just to be clear. This one now is a horizontal line because when y can be -2, x can be anything. X can be over here or over there. Whatever x value I choose, I'll be multiplying it by 0 because the slope is 0, and I'll just be starting at -2. So again, you can give a scale, -5, y equals -2. That's a good habit to get into. Okay, here I can choose to do this in any one of 2 ways. I could rearrange it into slope-intercept form by simply subtracting 1 from both sides, and there it is. It'd be 2x minus 1. So I could see the slope is 2, starting at -1, up 2 over 1, up 2 over 1, and so on. There's my line like that. Or I could just plot some points. I could just say, hey, if I plug in 0 for x, when x is 0, y is -1, and when y is 0, 2 times something is 1. The only thing that would work there is 1/2. So I could plug in these points, and then you could see I could plot them. It's a little bit harder perhaps. 1 or 0, -1, and then I would have that point right there as 1/2, 0, but it would still work. Okay, so this one is in slope-intercept form. Start at -3 and go down 1 over 2, or back 2 and up 1. But don't go negative. If you go -1, -2, you'll be going with a positive slope, and this has a negative slope. So just be careful when you do that, and again, give yourself a scale. All right, now, next page. This is more challenging because we're given 2 points, and we have to first successfully find the slope. So that's going to be rise over run. It's the long form here I've written out. I think the arrow method is the easiest way to go. Start with your y value and go to the next y value. 8 degrees down to 0 is cooling off -8. From 1 down to -3 is cooling off -4. That simplifies with the negatives canceling, and the 8 over 4 is 2. So the slope is 2. I can then put that into my template here, y equals mx plus b, and I can choose one point or the other. I'll choose this one because they're both positive numbers, even though having a 0 can make it a lot easier. But I'll just say 8 then for my y is going to be equal to my slope of 2 times my x value, 1, then plus b. I'm just replacing each of these with what I know them to be in this example up here. So that means 8 equals 2 plus b, subtract 2 from both sides, and 6 is what my b is. So my final answer is y equals 2x plus 6, okay? And you can always double check. When I plug in 1, do I get 8? Yes, I do. When I plug in -3, they cancel and I get 0, so that works. You can always check and be confident that way. Write an equation. Oops, this should say write an equation to model this. Sorry. An equation, all right? And I would say in this case I've defined water to be x and milk to be y. X plus y is going to be equal to 200 milliliter. All right, that's very, very simple. Just read and write. All right, now here a little bit more complicated. There's an initial fee of $5 to play mini golf, and then 50 cents for every hole you play after that. Okay, again, writing an equation, we lost that direction, but that's implied. So I would say that the total cost, like C, cost is going to be equal to $5 plus 0.5 x, okay, where x is the number of holes I played, number of holes, all right? And so then what's a reasonable domain and range? Well, the allowed inputs, how many holes might I play? I can't play negative holes of golf, and I bet 36 holes is like crazy lot, maybe 18, whatever is reasonable, but don't go thousands, don't go hundreds, don't tell me 0.5 because that would be silly. So I would say x is going to be greater than or equal to 0 and less than or equal to something like 36, 18, some reasonable number of golf holes. The range, the amount of money that I could pay, even if I pay nothing, I have to have an initial fee of 5, and then the cost is going to be, well, if I played 36 holes, then that would be 50 cents a hole is $18 plus 5 would be 23. So try to make these match, but again, I want to know that you have good judgment, you're not mixing up these quantities, you know that domain goes with the inputs, the x's, and the range goes with the outputs, so I wouldn't want you to mix up the 0 and the 5, but anything like this is okay, all right? Here's a look at the picture and write the equation. What's the rise and what's the run? Pick any 2 points. In my example, it looks like it's about 4 over 4, that's 1, and the b is 4, so y equals 1x, or x plus 4, very simple, all right? This one is then a number that's perpendicular to this, that passes through this point. This is like what we did on our last day. So I just know that perpendicular means that the slope is going to be the double Flipperooski of this fraction. So m, and they sometimes use a little perpendicular sign there, you don't have to do that, is -1/3. So that means I can take and replace m with what it's equal to, and then there's my x, there's my y. So 1 equals 4, whoops, I'll do -1/3. -1/3 is my slope, times 4 plus b. Well, that's going to be -4/3. So I'll write that down here. 1 equals -4/3 plus b. If I add 4/3 to both sides, that's 1 1/3 that I'm adding to both sides. So 1 plus 1 is 2. So b equals 2 1/3. Okay, I don't have quite enough space, but you can type that in your calculator. And then your final answer is y equals -1/3 x, then plus 2 1/3. Or you could write 8/3. All right? And finally, onto this, and we're going to get our calculator out and put those into L1 and L2. And when you do that, you're going to plot these, and then you will have, you will go into Stat and Calc and LinReg. Choose option number 4. You can hit Enter, Enter, and it's going to tell you what your A number is. That's actually the same as your slope. And I think that in this case, it's going to be something like 1.38 or something like that. I'm just going to save time and not get that. The B, when you do this data, is very, very close to like 1.005 or something like that, very close to 1. So you just are going to want to write the equation that y equals 1.38x plus 1.005 or whatever it is. You can then type that into the calculator, and you'll see that you get the LinReg line that's going to go like this. Then to make a prediction, you're going to simply take 400, because these are already in thousands, and these are in thousands here, and you're going to put 400 in right there, okay? And when you take 400 times this and add 1 to it, it's going to be something like 523 or 521, okay? But I want to keep this short to about 12 minutes, and you will see other videos that show you how to do this in detail, but that's what we're doing. Good luck, everyone.